Welcome to Ask and Learn.
So given this function and this domain, we know that the intercepts, the easy one is 0, 0, and the one that's a little harder to see that's within this domain is negative 1.20 and positive 1.20. So the symmetry is odd. The asymptotes, because you see a tangent here, it's every pi over 2n. So pi over 2n. And now we're going to see the increasing and decreasing intervals. So we have to solve for y prime. So let's do that here. Y prime equals 2 minus secant x, secant squared x equals 0. We're setting it to 0 to find the critical points. So x equals pi over 4. Pi over 4 is just the one that's in our domain, but it's obviously a trig function, so it's going to, have multiple values across different periods, but this is just in our domain. And so let's do a first derivative test for this. So it's every pi over 4, so we're going to have a negative pi over 4 in addition to the positive one. And substituting values in our first derivative that are smaller than negative pi over 4, we'll see that it's decreasing. Between negative pi over 4 and pi over 4 is increasing, and anything after pi over 4 is decreasing again. Alright, and if we want to solve for f of pi over 4 to find the y value for our, well, here it's negative to positive, so decreasing to increasing, so this is the minimum, and here is increasing to decreasing, so this is a maximum. So if we want to find the maximum, for example, the y value would be pi over 2 minus 1, which is approximately 0.57. Alright, so this is the first derivative test to show increasing and decreasing. Alright, and if that's our first derivative, our second derivative is going to be negative 2 secant squared x times tangent x. Alright, and if we solve, if we set it equal to 0, we see that x is equal to every pi n, where n is an integer. And so pi is obviously bigger than what's in our domain. We don't hit a pi, it's pi is out here, pi is out here. We're not within that. So, but we do see that since it's times an integer, we can do times 0 and get 0, which is our intercept. So we can test for 0 on our second derivative test for concavity. So this is f double prime for 0, which again is our intercept. So this is in our interval. So if we test for 0, anything less than is going to be positive. Anything greater than is going to be negative, which really means concave up and concave down. And since this switches from positive to negative, it switches signs, it's an inflection point at 0. And now we can graph. The first thing we can graph is the asymptote. Which is pi over 2n, so let's label that negative pi over 2 and positive pi over 2. All right, so let's label that in green. So these are our asymptotes. They're going to be vertical. So negative and positive pi over 2, we have asymptotes. And now we have a minimum value here at negative pi over 4. So if this is pi over 2, in the middle is going to be negative pi over 4. So let's say it's somewhere down here, and I know it's somewhere down here because we do know the y value for the max, which is, so pi over 4, and the y value is about 5.7. So if this is, let's say this is 1, negative 1, and this is 1. So then negative 5.7 would be somewhere here. And since it's odd, they're going to be like that because of the symmetry. Alright, so now we have our min and max, and we have the inflection point and intercept at 0, 0. And we have our other intercepts somewhere here. We're just going to do a rough sketch. So we have decreasing from, until we hit our minimum value, it's going to be decreasing. So it's going to look like decreasing, hit the axis, decreasing, and then hit our minimum, and then it's going to increase, and then it's going to decrease again, and it won't touch the asymptote, but it'll get really close to it. And let's check for concavity. So yes, concave up, and then we have the inflection point, and then concave down.